You have probably talked to a chatbot that forgot everything the moment you came back. That is not a bug. That is a memory problem. And solving it is what makes the difference between a tool and an agent that actually works. Welcome back to The Explainer. Today, we are dissecting the invisible architecture that turns a basic, highly reactive chatbot into an intelligent system that's actually capable of learning.
Right? I mean, think about what that would actually feel like for a second. Imagine trying to navigate this sprawling, complex city, but you don't have a map, and you have absolutely no sense of the turns you just made. Every single intersection would feel completely new. Now, sure, you could still physically move, but you'd be slow, you'd repeat yourself, and you'd be incredibly easy to confuse. Without memory, an AI is essentially just a one-turn machine. It can react to whatever is right in front of its face, but it simply cannot carry the past forward.
Section 1. The problem with forgetting. This brings us right to the core problem with what we call stateless agents. A stateless agent is a system that simply lives in the present millisecond. Without memory, an agent is literally just a momentary responder. Every single conversation starts from absolute zero. You're forever stuck on square one, having to repeat your goals and your constraints over and over again. But with memory, the agent actually builds on every past interaction. It remembers what it already tried. It remembers what failed, and it figures out how to stay aligned with your actual goals over time. It doesn't just reply to you. It continues with you. Section 2. What agent memory actually is.
So what does this actually look like under the hood? At a foundational level, memory exists because the current moment is simply not enough. Agents have to constantly balance two competing forces. On one hand, adapting to new, incoming information, and on the other, maintaining enough continuity so they don't completely lose the plot and start over. Now, a common mistake is thinking that memory just means saving everything. Actually, scratch that. Think of it more like packing a travel bag. You don't pack your entire house when you go on a weekend trip, right? You select the absolute essentials for that specific destination. Good agent memory isn't this massive warehouse where every random piece of data is dumped. It's a highly selective filtering system. It filters out the noise, it grabs what is immediately relevant, and it gives the agent's current actions a coherent history.
Because context completely changes the meaning of the present. There's a great saying for this. Memory is what helps an agent arrive not as a stranger to the situation, but as something that knows the scene so far. Imagine walking into a room right in the middle of a really complex conversation. You hear the words, sure, but you completely lack the frame of reference to actually understand them. Memory provides that frame. It's kind of like a smart thermostat. It doesn't just read the temperature right now in this exact second, it notices the historical trend of the room so it can avoid making wild, unnecessary temperature swings.
Section 3. How memory works in agents.
Okay, let's move from the philosophy of why this all matters to the actual mechanics of how it functions. How does the system operate in practice? Well, it's essentially a continuous, tightly managed cycle with three main jobs. First up, capture. The agent has to notice what actually matters, and this requires real judgment. Otherwise, the system just drowns in useless details. Second is store. It has to keep this selected information in a usable format. Now, this is a pure engineering problem, making sure data is durable and easy to interpret. And finally, retrieve. The agent has to recall that specific tiny piece of information at the exact right millisecond.
So you see, memory is an active process. It's not just a static box where things sit. It only truly works when the right piece of information survives the passage of time without degrading into mere noise and remains perfectly available for when the very next decision requires it. Section 4. Short-term versus long-term.
Now, to handle all of this efficiently without slowing down to a crawl, agent memory comes in different layers. You can think of it a lot like a physical workspace, well, really an office, where different systems keep context alive for different lengths of time. First, we have the context window. This is the agent's short-term working memory. Think of this as the papers actively spread out on top of your desk right now. It represents the immediate short-term information the agent is actively processing to complete the task at hand. It's fast, it's immediate, but it has very limited space.
But what about all those important details you're going to need later? That's exactly where the vector database comes in. This is the agent's long-term memory, stored as searchable patterns. If the context window is the top of your desk, the vector database is that deep, incredibly organized filing cabinet sitting over in the corner of the office. It securely holds older but deeply useful context that can be rapidly searched and brought straight back to the desk whenever the situation demands it.
Section 5. Real-world memory in action.
Let's anchor these technical concepts in a real-world scenario that we've all probably experienced.
Let's say you're trying to book a home repair service through an AI assistant, and you're sending messages scattered throughout a really busy day. At 9 a.m., you casually mention you're only available after 6 p.m. At noon, you specify that the location is downtown. And then later that afternoon, you add that it absolutely must be a Friday appointment. Now, a system without memory would treat every single one of those messages as a blank slate. It might suggest a Tuesday morning slot, completely ignoring everything you said earlier. But an agent with memory, it pieces those scattered constraints together across time.
By holding all these distinct facts together, the assistant does so much more than just answer isolated prompts. It organizes an ongoing, coherent conversation. It becomes dependable. It actually understands your entire working situation, not just the very last sentence you typed.
Section 6. The core of true intelligence.
Because here's the secret. Storing data, that's the easy part. But retrieving it, that is the ultimate test of true intelligence. Think of a massive library. A library with millions of books is completely useless if the cataloging system doesn't work. Behind the scenes, an effective memory system is constantly answering this incredibly difficult question. What from the past is exactly relevant to this moment? It's a delicate balancing act between precision and coverage. If it pulls too much, the agent gets totally distracted by irrelevant details. If it pulls too little, it forgets critical context and just repeats its past mistakes.
When this retrieval works perfectly, it directly shapes better decisions. First, it reduces repetition because the agent doesn't have to restart from zero every time you speak. Second, it improves consistency with your previous preferences. And third, it supports real adaptation by revising its behavior based on previous outcomes. Memory acts as this vital bridge where past information seamlessly influences future action right through the present moment.
And this leads us to our final takeaway. Memory is not just a feature. It is not a little toggle switch in a settings menu. It is the absolute foundation of intelligence itself. You see, memory is not what makes AI dangerous. It is precisely what makes it genuinely useful. It's the core mechanism that shifts an AI from being a very fast but very limited tool into a continuous system that actually learns.
If memory is what makes an agent intelligent, then what happens when that agent can search, reason, and retrieve anything it has ever learned? That is exactly what we explore next.